Okay, so today's video will be on the continuation of alkalis. Just to recap with you, the three reactions are acids, alkali plus acid, alkalis plus ammonium salt, and alkali plus metal salt. Okay, and these are the respective products. So, what is an acid? Or what is the reaction between an acid and an alkali, also known as? Okay, and acid also known as the neutralization reaction. Okay, write down the chemical equation for a reaction between hydrochloric acid and potassium hydroxide. Okay, so try this on your own first before you continue the video. Okay, so first let's write down the chemical formula. HCl and potassium hydroxide. Okay, what reaction is this? I know it's a alkali plus acid reaction. Okay, so it should give me the salt and water. So I write down water first. What is the salt? Remember that your acid always gives me my anion, okay, and my base always gives me my cation. Okay, so that's the reaction. So that's the reaction. Okay, now, is it a balanced equation? Let's check on both sides. Okay, here we only have one potassium, the right hand side also one potassium. One chloride, another chloride. Two hydrogen, and one oxygen, one oxygen. Okay, so this is a balanced equation. Let's add in the state symbols. Okay, again, acids must always be in equal state because an acid must be in water for it to behave like an acid. Okay, what about the alkali? Okay, note that this is an alkali, so it should also be in equal state. Okay, now let's go back to the solubility of salts. So, are chloride salts generally soluble or insoluble? Okay, they are generally soluble except for your silver chloride and lead chloride. Okay, so this is a soluble salt, it will be in equal state. And water is always in liquid state. Okay, now let's move on. Okay, the next reaction is the alkali plus ammonium salt reaction. We did this in the lab during PR2. Okay, so if you remember, what we did was we did an identifying test for the ammonia gas, which is to use the litmus paper test. Okay, if you remember, ammonia is a basic gas. Okay, so which lime paper would change color to what color? Okay, if you recall, it is a colorless pungent gas that turns moist red litmus paper blue. Okay, so it is red to blue. Okay, which tells me that it's a basic gas. The only basic gas you need to know is ammonia gas, whereas the acidic gas, there are quite a few. Okay, the two that you know is CO2 as well as SO2. Okay, this is the gas that's evolved when we use your sodium sulfide. Okay, so if you recall the lab, this gave me my sulfur dioxide gas. So these are both acidic gases, and when the blue litmus paper turns red, I cannot tell which of the acidic gas is it. So I need to do a further test. That's why for your carbon dioxide, your identifying test is not the litmus paper test, but the lime water test. Okay. So step 1, determine the products. Okay. For example, a reaction between sodium hydroxide and ammonium chloride. Can you try and determine the products now? Okay, first I must know that this is sodium hydroxide is an alkali. Okay, how I know it's an alkali and not a base? It's because first of all it's a metal hydroxide, so it's a base. Then I know that sodium hydroxide in particular is soluble, hence it's an alkali. So alkali plus ammonium salt gives me salt, water and ammonia gas. Alkali plus ammonium salt, water and ammonia gas. So water and ammonia gas is quite straightforward. What is the salt that's being formed? Okay, remember that for our alkali, we always produce the cation. So my salt will be sodium chloride. Sodium from my alkali, and then my chloride from my ammonium salt. Okay, and my ammonia gas came from the ammonium ion. Now, try this out yourself. Write out the chemical formula and balance the equation and add in the state symbols. Okay, ready? Okay. Sodium hydroxide is NaOH. Ammonium chloride is NH4Cl. Okay, anyone write NH3 is wrong. Sodium chloride is NaCl. Water is H2O. Ammonia gas is NH3, okay, not NH4, NH3. Okay, do not be confused still with ammonium and ammonia. Okay, different. Huh? So let's check, is it a balanced equation? Yes, it is. Now let's add in the state symbol. Okay, as I mentioned, this is an alkali, so it's in aqueous state. Ammonium chloride, if we recall the solubility of chlorides again, this is a soluble salt. Okay, sodium chloride is also a soluble salt. Water is a liquid and ammonia gas is a gas. Okay, so this is the balance equation. Oh. Okay, sorry, let me just remove the... Okay, so this is the balance equation. Okay, now we write down the balance equation for the reaction between potassium hydroxide and ammonium sulfate. Okay, try it out yourself now. Okay, so first, write down potassium hydroxide plus ammonium sulfate. Okay, sulfate is 2 minus, ammonium is plus, so I need 2 of ammonium to balance 1 sulfate. Gives me, okay, my cation comes from my base, so it's K. My anion comes from the ammonium salt, so it's sulfate. Okay, this is 2 minus, this is plus, so I must have 2 of it. Okay, it comes from K plus, SO4, 2 minus. Okay, plus water and ammonia gas. Okay, no space. Now let's check, is the equation balanced? Okay, not balanced. This one must have 2. Anything else? This one must have 2. What about my water? Should have 2 also. Okay, now the equation is balanced. Let's add the state symbols. Okay, use another color. State symbols here is aqueous. It's also aqueous. No, even though this is a soluble salt, okay, it can still exist as the solid state. If you recall the lab, right, we had the containers and then whatever is inside here, inside the container, this was a solid, right? But when we put it in water, they will dissolve. Correct? Okay, so they can exist in two states, the solid state when it's not in water and the aqueous state. Okay, so what state symbol we use here will be dependent on what is the experiment we are doing. So if we are adding two solutions, a solution of potassium hydroxide and a solution of ammonium sulfate to each other, then this state symbol is correct. But if we are adding the solution of potassium hydroxide to the solid stock of ammonium sulfate, then it's equals to solid state. Okay, is that clear? Okay, let's go on. Okay, the third reaction is the alkaline plus metal salt reaction. Okay, this is also called a precipitation reaction. Okay, this is because, if you recall, most metal hydroxides are insoluble. Okay, so if this is a soluble alkali, if this metal salt is also soluble, the salt is also soluble, and metal hydroxide is insoluble, which means it's a solid state. If we do the reaction, you will observe the precipitate forming. So a clear solution plus a clear solution will give me a solution with some solid. Okay, does it make sense? Okay, so again, the cation comes from the alkali, the anion comes from the metal salt. Okay, and whatever is left over will form the other compound. Okay, so recall that this one forms your salt here, sulfate forms your salt here. So what's left over is your magnesium hydroxide. Okay, so that will form your metal hydroxide. Okay, note that what happened here is the cations and anions are exchanged. Okay, so let's try and determine the products. Potassium hydroxide react with magnesium sulfate, give potassium sulfate and magnesium hydroxide. Now, can you write down the chemical formula and balance the equation? Okay, so potassium hydroxide plus magnesium sulfate gives me potassium sulfate and magnesium hydroxide. Note that here I need to bracket my MgOH2. Okay, it's not MgOH2 like this. Okay, this is wrong. Okay, this is correct. Okay, is it a balanced equation? Okay, no, right? We must have 2 potassium hydroxide. Okay, now let's add in the state symbols. Again, potassium hydroxide as the alkali must be in equal state. Magnesium sulfate is also soluble in water, so it's in equal state. Potassium sulfate is also equal state, but magnesium hydroxide is insoluble, hence it's in solid state. So what you will observe is a clear solution of potassium hydroxide is added to a clear and colorless solution of magnesium sulfate, and you will produce a white precipitate. Okay, so that's why this third reaction is also known as a precipitation reaction. This is because most metal hydroxides are insoluble. So when this metal hydroxide is also a soluble salt, then you will not see anything happening. Okay? So let's try this reaction. Okay, write down the balanced chemical equation for the reaction between aqueous, okay, calcium hydroxide and iron 3 chloride. Okay, so calcium hydroxide CaOH, one is 2 plus, one is negative only, so I need 2 of hydroxide plus FeCl3. Okay, I don't need to bracket around the Cl, gives me CaCl2 plus Fe OH3. Okay, so how do I balance this equation? I need 3 of hydroxide here, but only 2 hydroxides on the left hand side. So I take the LCM, I make these 3, I make these 2. So my hydroxide ions are correct. Okay, now I have 2 Fe on the right hand side, so I need to have 2 Fe on the left hand side. Now check, what else is not balanced? My calcium is still not yet balanced because there's 3 calcium here, there's only 1 calcium here. So I need to times 3. Check, is it balanced now? Yes, it is. Okay, so changing the color. What is the state symbol? I already told you that calcium hydroxide is aqueous here, and iron 3 chloride is also a aqueous salt. Okay, so it gives me calcium chloride, which is also aqueous, and iron hydroxide, which is insoluble, so it is a solid. So what you observe here will be your iron 3 hydroxide precipitating out. Okay, and the color of iron 3 hydroxide is actually your reddish brown. Okay, so iron 3 hydroxide is reddish brown. You see a reddish brown precipitate forming. Okay, so what do you think is more dangerous, a concentrated acid or a concentrated alkali? Okay, the answer is actually both are dangerous. As I've mentioned in class, actually alkali also corrodes. They both are corrosive. Okay, so they are both dangerous. It's not that acids are dangerous. Acids are just for some reason more well known. Okay, so which reaction is this? This is a neutralization reaction. Okay, the sting of a jellyfish is alkali, and vinegar is acidic. Okay, so that's all for acids and bases. Now, one more base I would like to point out that I haven't mentioned is your aqueous ammonia. Okay, you may think, how come aqueous ammonia is an alkali? Because where's the OH minus? Okay, it's because ammonia in water, it gives me your ammonium ions and your hydroxide ions. Okay, so when you see aqueous ammonia, it is the same as saying that there will be ammonium and hydroxide ions present in the solution. So because there's hydroxide ions present in the solution, aqueous ammonia is an alkali. Okay, so take note of this reaction. Okay, you may think that this arrow here is very strange. Okay, so what is this arrow? This is the reversible arrow, which means that the reaction can go this way, it also goes the other way. Okay, I will explain more about the reversible arrow in the next lesson when I talk about the strength of an acid and alkali. Okay, that's all. Thank you for paying attention. Please do the quiz to prove that you have watched this video.